Throughout our existence, we often look at the night sky. Depending on how dark and cloudless it will be, a picture of vast expanses inhabited by peculiar inhabitants, stars, appears before the earthlings. But does the sky have differences for an observer near St. Petersburg and, for example, near the Antarctic volcano Erebus? Certainly, it has. The picture of the sky depends on the location of the observer, as well as on the time and date of observation. That is why, from different points of the globe, it is possible to see constellations that dominate at certain times of the year. But in general, the Earth observer has not seen anything new for many centuries. The stars inhabiting the sky are the same. Let's ask ourselves a naive question. Why? The answer is not difficult. Our galaxy, with the romantic name of the Milky Way, or the Straw Man's Road, is a home to which there is no alternative for Earthlings yet. Therefore, we see part of the stellar population that lives in this giant system and 3 other neighboring galaxies, the large and small Magellanic Clouds, discovered by Fernand Magellan during his round-the-world voyage, as well as the Andromeda Nebula. In total, the visible part of the universe contains about 100 billion galaxies. The stellar population of the Milky Way, according to different calculations, is from 200 to 400 billion units. Why is the amplitude so large, you ask? But these are not coins in your wallet. You can't count them by pouring them into the palm of your hand. We have to act by indirect methods with the help of heavy-duty astronomical equipment and complex calculations. But the knowledge of Earth scientists is still insufficient for more accurate calculations, although some things have been found out for sure. First, the disk of our galaxy rotates around the center, the mass of which, according to the estimates of scientific men, is about 100 billion solar, and it is located in the constellation of Sagittarius. Secondly, in the center simply must pulsate the nucleus, which has the energy of 100 million suns. The density of stars in it is very high, much more than in the spiral arms, but this is not the most surprising thing. Astronomers suggest that at the center of every galaxy, including our own, is a supermassive black hole, and possibly more than one. Only if the object at the center has the specified mass and energy is the state of affairs we see now possible. Why do not we see this colossal formation? Simply, Earthlings observe Milky Way from the inside, circling together with the solar system around the galactic center at a speed of about 250 kilometers per second. The Sun completes a full revolution in 220 million years, and it is estimated that this has already happened 20 times. Respectively, the age of the solar system is 20 galactic years. It itself is about 28,000 light-years away from the center of the galaxy and is literally the backyard of our titanic home. Given the above, in general we see the same stars, only from different points we get slightly different horizons due to the Earth's rotation. So, what is the galactic population observed by Earthlings? They are giant stars, such as Betelgeuse in the constellation of Orion, which is 350 times the diameter of the Sun. This means that if there were a Betelgeuse system instead of the one we know, the Earth group planets would be trapped inside the luminary. But if we keep talking about the giants of our galaxy, that's not the limit. For example, the Epsilon of Ascendant leaves Betelgeuse far in the rearguard. The size of this infrared supergiant is 3.7 billion kilometers across, so if placed at the center of the solar system, it would occupy all the orbits of the planets up to Uranus. The luminosity of this stellar monster is 60,000 times that of the Sun. There are on our horizon and white dwarfs, very small, no more than the Earth's size but too hot, from 5 to 50,000 Kelvin, and heavy, the mass comparable to the Sun. Correlating these parameters, it is easy to understand that the density of matter of such stars should be simply monstrous, exceeding solar in hundreds of thousands of times. According to astronomers' calculations, 1 cubic centimeter of white dwarf matter will weigh several tons. In addition to stars, our Milky Way is populated by gas and dust nebulae, asteroid belts, planetary systems, and black holes. This is the sky we will see as long as we live. And in it sparkles the star that is most important to us, the star that makes humanity exist, the Sun. Its lifespan is past up to half, but its heat and light will be enough for our age. And there, who knows, perhaps people will find an opportunity to travel in search of another home, located near another star torch. And there, people will see a completely different sky. What do you think about this? Share with us your opinion in the comments, and be sure to subscribe to our channel and public that would not miss all the most interesting, all links on the screen and in the description.